This video is on Laplace transforms. The directions say to find capital F of S. The examples are based off the first translation theorem, which says the following. The Laplace transform of e to the at f of t is equal to capital F of S minus a. Let's take a look at some examples. In example 1, we want the Laplace transform of te to the 10t. A is equal to 10, right here. And we want to note that the Laplace transform of t is 1 over s squared. And so the Laplace transform of te to the 10t is the Laplace transform of t where s is going to be replaced with s minus 10. That's what essentially this piece means. We're going to take s and replace it with s minus 10. And when we do that, we get 1 over s minus 10 squared. In example 2, we want the Laplace transform of te to the negative 6t. So a is equal to negative 6. And so this is equal to the Laplace transform of t where s gets replaced with s plus 6. And again, the Laplace transform of t is 1 over s squared. And so when we replace s with s plus 6, we get 1 over s plus 6 quantity squared. That's example 2. Example 3. Suppose we want the Laplace transform of t cubed e to the negative 2t. Now, a is equal to negative 2, and the Laplace transform of t cubed is equal to 3 factorial over s to the 4th, which is equal to 6 over s to the 4th. So that's right here. Now, let's put this together. The Laplace transform of t cubed e to the negative 2t is the Laplace transform of t cubed where s gets replaced with s plus 2. And when that occurs, we're going to get 6 over s plus 2 all raised to the 4th power. Example 4. Suppose we want the Laplace transform of t to the 10th times e to the negative 7t. Well, in this example, a is equal to negative 7. So this is equal to the Laplace transform of t to the 10th, where s gets replaced with s plus 7. It's really slick. Now, the Laplace transform of t to the 10th is equal to 10 factorial over s to the 11th. And so the Laplace transform of t to the 10th e to the negative 7t will be 10 factorial over s plus 7 raised to the 11th power. And that's example 4. Example 5. Example 5 is really good. So suppose we want the Laplace transform of t times the quantity e to the t plus e to the 2t raised to the 2nd power. So your first step is you need to square out e to the t plus e to the 2t. And when we do that, we get the Laplace transform of t times the quantity e to the 2t plus 2e to the 3t plus e to the 4t. And then from there, I'm going to distribute the t inside to each term within the parentheses. And when I do that, I get the Laplace transform of te to the 2t plus 2te to the 3t plus te to the 4t. And it's really important you want to break this up. And when we do that, we get the Laplace transform of te to the 2t plus 2 times the Laplace transform of te to the 3t plus the Laplace transform of te to the 4t. And so I'm going to take each term separately. And remember, in the first term, a is equal to 2. In the second term, a is equal to 3. In the third term, a is equal to 4. And in the second term, just remember the 2 goes along for the ride. Okay? And over here, I get the Laplace transform of t where s gets replaced with s minus 2, plus 2 times the Laplace transform of t where s gets replaced with s minus 3. And so if you don't mind, I'm going to draw a vertical bar here and over here. So here, s gets replaced with s minus 3. And in the third term, s gets replaced with s minus 4. So when we put everything together, we get 1 over s minus 2 squared plus 2 over s minus 3 squared plus 1 over s minus 4 squared. And so again, don't forget the Laplace transform of t is equal to 1 over s squared. So we need that to be able to finish the problem. Example 6. So suppose we want the Laplace transform of e to the t times sine of 3t. Now, down below, notice how I wrote the Laplace transform of sine of 3t is 3 over s squared plus 9. So the Laplace transform of e to the t sine of 3t is the Laplace transform of sine of 3t where s gets replaced with s minus 1. And so this is 3 over s minus 1 squared plus 9. But remember, s minus 1 squared is s squared minus 2s plus 1. And when I put that together, I get 3 over s squared minus 2s plus 10. And that's because 1 plus 9 is 10, and hence I'm finished. Okay, that'll do it for this video. We looked at Laplace transforms. We specifically focused on the first translation theorem, and we did 6 examples. Thank you.